The long-range navigation station at A and B are 500 miles apart, and the ship at P receives station A signal 2640 microseconds before it receives the signal from station B, as in this figure. Assuming that the radio signals travel 980 feet per microsecond, find the difference in the distances between P to A and P to B. Find the equation of the upper branch in red color. If A is due north of B and P is due east of A, how far is P from A? First, we see that the distance is the times elapsed times the velocity. So the distance from the point P to A is the velocity times the time from the station A. And the distance from the point P to the point B is the velocity times the time from signal B. We're looking for the difference in the distances, so the distance from PA to the distance from PB. But if we take the difference between the two, then we also have V times TA minus V times TB. And this is V times the quantity TA minus TB. We don't have TA and we don't have TB, the time that the signal travels from station A to P and station B to P, but what we have is the difference between the time. And we were told that the ship P receives station A signal 2640 microseconds before ship A, and so the time difference is 2640 microsecond. The velocity is also given 980 feet per microsecond. So although we don't know TA and TB, we successfully evaluate the expression on the right hand side, and the left hand side is the difference in the two distances, which is what we want. dPA minus dPB. Compute the right hand side. We have 2,587,200, and this is in feet because microsecond cancel microsecond. To obtain the distance in miles, we would multiply 1 miles is approximately 5,280 feet. So feet and feet canceled out. This gives us 490 miles. This is the difference between the two distances, the point on the hyperbola to one foci, and the same point on the hyperbola to another foci. By the properties of the hyperbola, the difference between the two distances has to be 2a. That is how we obtain the equation of the hyperbola. We set the difference in the distances to be 2a. Therefore, a equals 245. Also, C is 250 because A and B are the foci of this hyperbola. Now that we have A and C, we should be able to find B. In a hyperbola, C squared equals A squared plus B squared. C is 250, A is 245, and so B squared is 250 squared minus 245 squared, and this will give us 2,475 being B squared. So for part B, the equation for the hyperbola is y squared over a squared, but a is 245 minus x squared over b squared. B squared is 2475 equals 1. 245 squared is 60,025 minus x squared over 2475 equals 1. If A is due north of B and P is due east of A, how far is P from A? If P is due east from A, then P and A are on the same horizontal line. What this means is that the y-coordinate of the point P is also 250. We don't know what x is. To find x, we just simply plugged this point into the equation. And so, knowing that the y-coordinate of the point P is 250, and this point is on the parabola, so it has to satisfy the equation, we have 250 squared over 60,025 minus x squared over 2475 equals 1. If we isolate this, we will get x squared approximately 102.05, where x will be approximately 10.1. And so point P or ship P is approximately 10.1 miles from station A.